Shazan, have you done this question? Last time I gave, try this.
Okay.
Try, then I will discuss. Hello, Ridhima. Last time I gave you a question. Okay, if you have done, then it's okay. Or else you can just try, give it a try. You have to use BPT. Okay, the first part that is given. Okay, before or. Okay, that one is clearly mentioned the figure. Okay, in this it is clearly mentioned the figure, but in the next one you need to little bit imagine the figure and write. Only trapezium it's written. Okay, now you have to think about it. Okay. I'll give you a hint that construction is required here. You need to join this.
Two diagonals.
Name it as G or any other point, whatever you feel like, O or anything. Now try it. If you see here, it's mentioned here that AB is parallel to
Ma'am, DC.
DC. Okay, and EF is also written. EF is
Parallel to
parallel to AB. Now the parallel to same thing, they can be parallel. Okay, so EF will be parallel to DC also.
DC, yes, ma'am.
Okay, now since you can see in now check in triangle A.
Ma'am, BC, ADC,
In triangle ADC, EF is
ABC.
parallel to DC, which imply actually from BPT. By BPT, what you got? AE by ED is equal to AG by GC or CG. I can write in fact that will be better. CG. Okay.
Okay.
You can name it as equation 1. Now again in triangle ABC, what you can see, FG, in fact you write here G only because this is a part of the triangle. Okay, part of the parallel line. So FG is parallel to AB. Okay, so what you have from BPT, by BPT, what you got? CF upon BF is equal to AG upon CG. Second, wait, I have written AG. If I have written AG upon this, then I have to write here also. I have written AG plus BF on FC. Or if you have written CF upon FB is equal to CG upon GA, so you can reciprocal it. Okay, you will get the same thing. Understood? After reciprocaling, you will get this. Okay. Now from equation first and second, what you got? If you see here, they are same, they are equal to the same thing. So you can write what was written in the proof, AE upon ED. Na?
Ma'am, AE by ED is equal to BF by FC.
BF by FC. Got it? Understood, Ridhima? And Shazan, both of you, any doubt? If you want, you can take the screenshot with the complete way of writing. Okay, because in examination you need to mention every point. Okay, which theorem you are using, how they are parallel. Okay, everything you need to mention. Okay, all the theorems and all. That's very necessary. Okay, and in the end, this was the proof part, given part, to prove, construction. These all the steps are very important in your geometry. Whenever you are doing any question of geometry, always write the given, to prove, construction. If construction is there, then write construction. If not, no necessary. Diagram and the figure and the proof. Okay.
Now, the construction was there in the second question, right? Not the first.
First one.
The
So both
AC
the questions
connection.
are the same.
These were
both
the all
questions-
questions.
both the question are the same. Okay.
Oh, they are the same?
The way of writing is different. Okay. In the first part, in this part, everything was mentioned. Okay. Every detailed was mentioned about the figure. But in the second part, if you see in a trapezium, what was mentioned? That the figure is trapezium. Now what mentioned? See, show that any line drawn parallel to the parallel side. Or you are drawing any line that is parallel to the parallel sides. Matlab, two sides which are parallel, you are going to join a third line which is parallel to all both these sides. Okay, of the trapezium divides the non-parallel side proportionally. They are dividing the non-parallel sides proportionally. Which are non-parallel sides? In this figure, if you see AD and BC. Now, if you are joining, you're drawing a line which is, and it is telling you that it divides the line proportionally. That means AE upon ED should be equal to BF upon FC. The same thing is there, but in only the statement form in the second one. Only statement form is there. Okay. So sometimes we get confused in only the statement form, but it is saying this only. So you need to focus on these type of question also, because one or two means one question you will get this type also. Okay. When everything is mentioned, it's not tough to do. Okay. But when in statement form is given, sometimes we are not able to figure out. Oh, the problem. Okay. This is there in the joining figure. I need to copy the figure also. 9 minus. Now you see here in the joining figure, PS upon SQ, it is already mentioned. So here given, if you write here given, so what is given? Triangle PQR. Triangle PQR is given, where PS upon SQ is equal to PT upon TR. Okay, and angle, and what else is given? And angle PST is equal to angle PRQ. This angle is equal to this angle. It is mentioned already. Now what you need to prove? Okay, PQR is an isosceles or either you write this, it's better to write what? Angle PQR is equal to angle PRQ. Okay, if isosceles triangle, this only happens. Okay, either you can prove that the opposite sides are equal, or you can say that the opposite angles, the two of the angles are equal. Yes. So how can you prove that these two angles are equal? Any hint? What is
we can draw.
from the given? What you can say?
And we can prove that ST and QR is parallel.
Yes. How can you
From
prove that ST is
Ma'am,
parallel?
by converse theorem.
Yes, ST is parallel to QR. Okay, from converse of BPT. Okay, now from converse of BPT, we already know that ST is parallel to. You have to mention here converse of BPT or converse of theorem. So ST are parallel to QR. Now, if ST is parallel to QR, so you can say that angle PST is equal to angle PQR, because both the lines are parallel. So corresponding angles are equal.
PRQ, right?
PQR, ये वाला दोनों एंगल की मैं बात कर रही हूँ, इस एंगल और इस एंगल की, ये दोनों इक्वल हो जाएंगे.
Okay.
Yes or no? Corresponding angles.
Okay.
ये जो parallel line ऐसे pass होती है and there is a line, so you say that this angle is equal to this angle.
Yes, ma'am. I understood that. Okay. Corresponding angles of parallel sides are equal.
This because corresponding angles are I'll write corresponding equal. Okay. Now angle from, you can say from this one, from first and second. What you got? That angle PQR is equal to angle PRQ. Okay. Yes or no?
Yes, ma'am. But you have to prove it is isosceles.
You have to prove that it is an isosceles. Now, since these two angles are equal, so it will be an isosceles triangle.
Okay.
Got it, Pradima?
Oh, I understood.
See, if you need the statement form, I have written the proper statement here.
Understood. Ma'am, the PQ and PR, ma'am, they are equal, so the opposite angles will also be.
Okay.
Yes, ma'am.
And which implies you can say PQ is equal to PR. So there the opposite angles are equal and the opposite sides are equal. So a triangle is a isosceles
triangle.
Statements are very important in your geometry. You cannot miss a statement. How you are proving, why you are proving.
Okay, ma'am.
Now, this was the first means what different types of question you will get in BPT. Now, second of the type is that what type of question you will get in BPT. Sometimes basic proportionality theorem or its converse is used for finding the length of unknown sides. Okay, like the two sides are parallel, so you can find the four of the sides are there, four portions are there. Na? So one of the portions value is not given. You need to find one of the length is not given, so you need to find out. So in that case, you can use this basic proportionality theorem. Okay, you can try this one. This is very easy. I'm not drawing the figure. Figure is very easy and simple. There's nothing much in the figure. It's just a triangle. Wait, you need measurement. I mean, value na. A, B, C, D, E. A, B, C, D, E. Try it. It's just very easy. So what is there? Since DE is parallel to BC, actually since.
8 centimeter.
Yes, therefore AD upon DB is equal to AE upon EC from BPT. Okay, so what it will be? A की value क्या है? 3.
Ma'am, 8 centimeter, ma'am.
Yeah, I'm just writing it down. Okay, so which will imply that EC will be equal to. Okay, now similarly, you do one more question. That is also very easy one. Tomorrow is your test, remember?
Yes, ma'am. Practiced a lot of questions. Ma'am, only 4 theorems are there in circles, right?
4 theorems? Only two theorems are there in circle.
No, 4 are there.
The theorem and the converse. So you can say 4 theorem.
Okay, now you can put.
Try this one.
This one.
What is the answer?
Wait, ma'am, I went somewhere wrong. I did a little bit of mistake.
Okay, do it. After this, the topic is similarity.
Okay. Ma'am, no, wait.
Vida, have you got the answer, Dima?
No, ma'am. Can you show the solution once? I will just check with mine. The
I'm
final
just
answer is wrong.
the 2010.
Oh, wait. It's a decimal only. Okay, then it's correct.
10.5 centimeter. Tazan, have you got the same answer?
I just did somewhere. It's okay. And I understood.
Okay, have you understood now?
Yes, ma'am.
Ma'am, but I did something else, not the one.
How you did it?
So, the ratio I took as PQ by PS is equal to PR by PT.
PS by?
No, PQ by PS and PR by PT.
Okay.
Hmm.
So, what ratio was given in your question? PS by SQ. Can you send me the image? I'll see.
Yeah, ma'am.
Because orally in geometry, na. Yeah, so you did PS by S. Yeah, PQ upon PS is equal to S. So 84 upon 8 you got, na? Okay. You can do that way also. Fine.
Okay, ma'am.
Okay. Now the criteria of similarity. Similarity of triangle, you know that congruency and similarity, two things are there. Congruency means the figure should overlap each other. Okay, it should be exactly upon the another. Okay, like identical twins, they look exactly and everything is exactly if it is. Okay, but similarity means they look similar. Okay, they will not overlap. It's only similar. Like isosceles triangle, all the isosceles triangles are similar triangles. Okay, all the scalar triangles are similar to each other. Okay, but if I'll try to compare isosceles triangle to a scalar triangle, it will not be similar. Okay, in similarity, size doesn't matter, only your they should be look alike. Okay, now how can you say the two triangles are similar if all the three angles are congruent? Sorry, all the three angles are same, and if all the three sides are in the ratio, okay, then you can say that the triangles are similar. Now in congruency also, what we do, all the three sides should be equal there and all the three angles should also be equal. But when we are proving that the two triangles are congruent, then we don't require to prove all the six of the qualities. Okay, we choose three of them. Okay, similarly in similarity also we can choose three of the angle, side, or whichever. Okay, so they are rule. Okay, not like anything you can choose. Okay, so the first one is AAA similarity criteria. Either you can use AAA or simply AA. Why? Simply AA will also work because if you have proved that two angles are same, if two angles are equal, obviously you know the third angle will be automatically equal because the sum of the angles of the triangle is equal to 180 degree. Okay, so the third has to be equal. So if you have got two angles also equal, so you can write a similarity also. Okay, or you can prove if you have got all the three angles, so you will use a similarity. So the first one is a similarity. Here in this, you are going to prove that all the three angles are equal. Now, if you see your proof, now we have two triangles. Okay. Now what is given? I'm telling you the proof of AAA. Okay. Now two triangles are given. So obviously we need to prove they are similar. Sorry, that means the size is not equal. Okay, only they're similar. So what I have taken, I have taken two triangles. One is ABC and another is DEF. Now I'm doing some little construction. I am cutting from DEF. I am taking DPQ. Now, how I am choosing this DPQ? I'm taking DPQ in such a way that DP is equal to AB. This is equal to this one, and this is equal to this side. Okay, and obviously the third one is PQ is equal to BC. Okay, but first right now I'm cutting this, I'm marking this point P and Q in such a way that AB is equal to DP and AC is equal to DQ. Any doubt? Now what we need to prove? We need to prove that they are congruent. That means the here A criteria is there. That means it is given that all the three angles are already equal. Okay, now the other point we are going to prove, that is all the three sides are in proportion. Okay, that means AB upon DE is equal to AC upon DF, and BC is upon EF is equal to. Okay, and since it is a ratio, so always ratio will be less than 1. Okay, now how we have proved? Now, as you can see, with the help of construction, AB is equal to DP, AC is equal to DQ, and angle A is equal to angle D, because that is the given in the question. Okay, so from these three, okay, two construction and one given, we can say that both the triangles, that is the triangle ABC is congruent to triangle DPQ. I'm talking about DPQ. They are congruent. These two triangles are congruent. Okay. Now we can say that angle P. You can say that angle P is equal to angle B, and angle Q is equal to angle C from the CPCT. Okay. Congruent corresponding parts of congruent triangle. Okay, now we have got all the three angles are equal of this also. Okay, but in the starting only we know that angle A is equal to angle B is equal to angle E, and angle C is equal to angle F. Okay, angle P is equal to angle E. Okay, that means, what does it mean? This angle is equal to this angle. So what does this mean? Why? Because this angle is equal to E and the B angle is equal to P also. So P and E are both equal. That means it makes PQ is parallel to DF. Yes or no? Corresponding angles. PQ is parallel to DF. You can say, now if PQ is parallel to DF, what does mean? We can apply basic proportionality theorem. Okay, so from basic proportionality theorem, I have written this. Okay, dp upon p. I'll draw the figure here again, or I can copy so that you don't get caught. I'm pasting it here so that it's visible with the. Wait, no problem. I'll draw it. Okay, I think some problem is there. One triangle was A, B, C, and the another triangle was D, E, F, and I have taken a construction of PQ. Now, since P and Q, we have proved that PQ is parallel to EF. So in this triangle, we are going to apply BPD only in DEF. So in DEF, if you apply BPT, so you can see DP upon PE is equal to DQ upon QF. Okay, you see. Okay. Now, if you reciprocate, so PE upon DP is equal to QF upon DQ. Any doubt till here?
No.
Okay. Now I'm adding 1 on both the side. Okay. Why I'm adding 1 on both the side? Because I'm taking I want the full length. Okay. in the ratio, like you applied in the last question, Ridhima. Okay, you taken the full length and the half length. So I'm adding 1 for that purpose on both the sides. Since I'm adding 1 on both the side, so it will not affect my equation. Okay, so after adding 1 on both the side and solving, what I got, that DE, the complete length, this complete length upon DP, okay, upper one, okay, is equal to DF. Why I'm doing this? Because DP, I can equate DP to AB and DQ to AC. Okay, so now when I have got this, now I'm going to replace DP and DQ to AB and AC. Okay, from first and second equation, here. Okay, this one. So after equating it, I've got that AB upon D is equal to BC upon EF. One of the ratios I've already got. Now, similarly, you can, from the equation third and fourth, we can get this from this equation and this equation. Understood? AB upon DE is equal to BC upon EF. Now, since you have the angles are already given equal, now by using the basic proportionality theorem, we have already proved that the ratios are also equal. So since the ratios are equal, so the triangles are similar. Okay, when you're proving the two triangles are similar, so actually two things are required. All the three angles should be equal and all the three sides should be in proportion. Okay, but this is the theorem. This is actually, I'm explaining you that how we can say, how we can use AAA as a fulfill criteria. मतलब सिर्फ AAA को use करके कैसे कह सकते हैं? How can we say that the two triangles are similar? But when you are using this AAA criteria, you don't need to mention, only you need to mention which three angles you are taking. You don't need to do the proving. Okay, this proving is for you to understand that how this theorem is derived. Okay, how we are using AAA, how this come into existence. Okay, so what is it? You can say now similarly it is another way. Where's the second one? This was the first one. I'm missing something. Okay, second one has come here. I think page is swapped. Okay, no problem. Now the second one comes SSS similarity criteria. Now what does this SSS? SSS means all the three sides are in ratio. Now here in this theorem, what is given, that all the three sides are in ratios given to you. Okay, now actually this is the criteria by using just but if it is asking you that two triangles are given and you need to prove that the two triangles are similar, so you can, if three sides, if you are able to see three sides which are in the ratio, you can find that both the triangles, all the three sides are in ratio. So you can simply write that from SSS criteria we can say the triangles ABC is similar to triangle PQR. Okay, now I'm explaining you here how you are using SSS, how this criteria fulfills. Okay, or how you are just going to use SSS. Okay, so since SSS means ratios, the sides are in ratio, so this is a given part that the sides are in the ratio. Okay, now what you need to prove, that all the three angles, the second part of the similarity of triangles, that all the three sides should all the three angles should be equal. Same thing we are going to do. We are going to do a little bit of construction. We are going to take DP. We are going to cut DP from DE in such a way that AB and DP are equal. Similarly, AC is equal to DQ. Okay. Now you know both the triangles are okay. Now it is already given the ratio are equal. Okay. That means AB upon DE is equal to AC upon DF. Okay. Now this implies that instead of AB, you can write DP. Okay, because AB and DP are the same. Okay, so DP upon D is equal to DQ upon DF. Okay, now which means that here we are using converse of BBD. Okay, since the ratios, this and this ratios are same, so we can say that PQ is parallel to EF. Any doubt till here? Okay, we can say that PQ is parallel to EF. Okay, now since PQ is parallel to EF, so you can say that angle P is equal to angle E and angle Q is equal to angle F. Okay, we are doing just what we have done in AAA, we are doing the reverse of that. Okay, there we have proved since the angle are equal, then we said that the PQ is parallel to EF. Here we have proved BQ is parallel to EF, therefore the angles will be equal. Okay, now if you see here, since the angles are equal, therefore the A is equal to angle D already. Okay, sorry, not angle A, it's not mentioned. Since B is equal to angle E and C is equal to angle F, so that means already from 180 degrees sum of 180, A will be equal to D. Okay. So from AA criteria here, you can write that the two triangles are similar. Okay. Whenever you get the two angles are equal, then you don't need to prove the third angle. You can simply write AA criteria also. Okay. Because the third angle automatically will be equal. Now here we have proven that these two triangles DPQ, okay, in the same triangle we have proved that the two triangles are similar. Okay, now what we need to prove? We need to prove ABC is similar to DEF. Yes or no? Okay. Now we since these two triangles are similar, so we are going to use the proportional side of these two triangles. That means DP upon DE is equal to DQ upon DF is equal to PQ upon EF. Okay, if you see here, and then we are going to replace the equal parts. Okay, if you are going to replace the equal parts, then you will get the two triangles are congruent. Any doubt in AA or SSS criteria? Now I'm leaving one of the criteria on yours, okay, because it is also same way, okay, same type of construction and same thing are there. Okay, now what is this SAS? Now I will explain this SAS. Since you can see angle is between the two sides. Okay, so whenever you are having two triangles which you need to prove as similar, like one of the angle is given that is equal. For example, this is the angle that is given to you that it is equal. So always take the two sides should be the sides that is making this angle. Okay, like this one and this one should be there. You cannot take this third side. Understood? Always take the side which is beside this angle. Okay, so this is equal to this is corresponding to this and this is corresponding to this. You have to prove. Okay, this is the given part. The angle and the two sides that is making the angle that should be in the ratio. Understood? SAS. So we have seen three criteria: A for similarity, AA, SSS, and SAS. From the name itself, you can say SAS. Angle should be in between. Anything I'm not leaving now here. Now, if you come on the problem based on this similarity of triangle, can you just quickly do this? It is a very simple question. Okay, can you tell me which of the triangles are similar actually? Wait. Okay, these are the three triangles you need to compare and check. Okay, now here you can see all the three sides are given. Okay, so you can check the ratio of all the three sides and tell which of the triangles are similar to each other. Okay, maybe first and second can be similar, maybe first and third can be similar, maybe third and second can be similar. So you need to tell me. Can you check and tell me? And its time is also, or you can take it as a homework. Okay, take it as a screenshot. Time is already up, and wait, I'll give you this one also. Okay, take the screenshot of both the questions. Is it there? Visible now?
Took the screenshot.
Ridhima?
Yes, ma'am.
Any doubt in any of the criteria for similarity? So in the next class, that will be, I think, on Thursday only, because tomorrow you are having a test. Okay, we will just 2-3 example, then area of the triangles. Area of triangle is not a big deal. Only one single theorem is there. You need to okay, this theorem is for explanation, but I'll tell you because maybe sometime it can be asked also that how can you say that the area of the triangle of the ratio of the triangle is equal to the square of the ratio of the sides. Okay, so this is the only one theorem and some question based on this, and then you are having Pythagoras theorem and its converse. This is an also important theorem. Okay, these theorems are very important, and on Monday we'll have assignment. Okay, Pythagoras theorem, converse of Pythagoras theorem, and then your whole course will be finished.
Ma'am, tomorrow both the classes, the test will happen?
Yes.
Okay.
Circle test is there. Okay, you have just finished circle. Say, because many time it happens now that if I'll take only one class, if I give you only one class, so your time is little short, because in examination you get little, 3 hours you get now, so it will be, so that's why 2 classes are consumed for the test. Okay?
Ma'am, how much marks?
I think it will be 40 or 50 marks. I think circle paper I have prepared for 40 marks only. Generally, you'll have 50 marks paper, and after when you'll finish this triangles, I'll have some of the test, and then you will be having 2 chapters combined test. Okay, I think 6 or 7 papers are there, and after that maybe 1 or 2 papers you'll have as your examination type of paper. Okay, some sample paper type. Okay, so that you can know that yeah, it's what's your preparation. Okay, and after that, obviously, your exams will also start from February or else. Okay, fine.